Once my teacher told me, add a 2 kilogram to the 4 kilogram placed in the table. I just add 2 kilogram and she said, good boy, but there's no matter in that. But when I'm walking through the road once, I saw a man, he's holding a 25 kilogram stone is in his hand and the stone is under pressure. Any time it will fall down, and he asked me help to push the stone. I just pushed from the upside to the downside and it fell into his hands, and the man's hands got bleeded and it gets broken. What's wrong here? What's wrong with happens here? The wrong is the man didn't say which direction should I give the force, whether it from upside down or to the downside, to the upside, to the right side, any direction I can apply the force. That is because the force is a vector quantity. We need to specify the direction. But in the case of the mass, we don't need to specify the direction. Anywhere you can add. You can add from here to here, you can add from here to here. This term will completely will say as 6 kilogram. This comes with the definition of vectors. While specifying the vector, you need to mention the magnitude and direction. But in the case of the scalar, you need to only specify the magnitude. There are a lot of vectors around us, like force, velocity, momentum, acceleration, and also the scalars. There are masses, time, and speed. Yeah, these are the scalars. And there are one more explanation for the vector, and I will show you it through an example. Suppose there is a ball of mass m is moving with the velocity v in this direction, and I place two peoples, Nigga and Giga, at the two positions, and their peculiarities are they can only see the particles above their heads. Like the Nigga can see the ball is moving in this direction only, and Giga can see the ball moving in this direction only. And from the reference of the Nigga says that, well, after 1 second, the ball moves this much distance. So the velocity of the ball, if it is theta, then the velocity of the ball becomes v cos theta. And Giga says that after 1 second, the ball moves this much distance, this. So the velocity of the ball is v sin theta. Yeah, both of them are correct. None of them are wrong. But what is actually wrong here? That we need to find. Nothing is wrong here. These two are the components of this vector from the two different axes. It is a y-axis and it is the x-axis. And these two are the components. These two are the vectors actually. And the original vector is a sum of these two components, two component vectors. And I have one more question, that if I give a momentum of mv cos theta in this direction, what should happen to the ball? Well, from the reference of the Nigga says that, yeah, it has a momentum of mv cos theta in this direction. So if I give mv cos theta in this direction, then it should cancel with each other and it does not have any velocity. Nigga says. Giga says that, well, it has v sin theta in this direction. There is no other momentum comes because he can only see the motion in this direction. So what would happen? The vector will change. But the question is, how to represent the new vector? Yeah, well, firstly we can use the Nigga's observation. That is, the velocity of the vector is 0. So here is a particle. It only has the vertical component can exist because the horizontal component is 0. We are adding mv cos theta in this direction. So Nigga says that the particle is at a rest in this direction. So the velocity becomes a straight line. And do you think what would happen if we add more than mv cos theta? More than mv cos theta, then what should happen? Well, Nigga says that it already has a momentum of mv cos theta in this direction. So if we add more than mv cos theta, then there will be some net momentum in this direction. And Giga says that there is nothing to change. It will be same as in the previous case. So what should happen? Let us redraw what situation is. Let I give a momentum of k in this direction, and k is greater than the mb cos theta element. So how can I create the new vector? Like, how would be the direction of the motion of the ball? Yes, just try to put it in this direction. Like if you place k here, it should be the thing after that. And if you draw a line here, this is the mb cos theta component, and it will fully get cancelled by this k, and the k has a small element in the opposite direction. That's why here we need to look at the ball. Here it has a momentum in this direction, and this momentum is nothing but k minus mv cos theta. And the giga says that nothing has changed. It has the same velocity in the direction, upper direction. So what should we do? Like, this is the two new component. So if you draw a vector, this should be the vector. This is the thing. And if we rub the other elements, then we can show that it is actually a triangle. This is the triangular law of vector addition. That is, place the adding vector here. Actually, we are added the vector v plus vector k. We just place the vector k in the head of the vector v and draw a line from the tail of the vector v to the head of the vector k. This is the resultant vector. This is the new vector, and I just show you how it comes. Suppose we have a vector like this with a magnitude v, and the question is, how do we represent this vector? You may say that, yeah, well, I will draw this in the book and I will show this to everyone that this is a vector I found it. Yeah, that's true. That's very nice observations, but you may not get marks for that. In order to represent a vector, we use its components, like how much is it in while it looking from the x-axis, that vx is a component of the x-axis. Like the previous case of the vector, that a person looking it from the bottom side, there is a vx, this vx is component is the component of the vector, that how this vector is going with the x-axis looking. Like that, there is a y-axis component. Like that, there is a z-axis component. And another question is that how do we represent this component? Yeah, for that we have some elements, that is I cap, j cap, k cap. For this vector v, we can represent it as vx I cap plus vy j cap plus vz k cap. Why we need to represent like this? I have the answer. I will show you. Let's consider that we taken the vector v with its components, and we took another vector also, the vector a. My question is, how do we calculate vector v plus vector a? Then yeah, you may ask me, you may say that let's take the vector v as like this, and vector a in this direction, vector a and vector v, and just draw a line like this. This should be the resultant vector, and which is equal to the vector vector v plus vector a, as we have it solved in the previous case. It is a law of triangular law of vector addition. Yeah, it's a very good, nice observation, but it is very complex. It is very messy that you cannot draw every time these diagrams. So what do you do in such situations? How do we calculate the vector v plus vector a? How do we find the answer? Yeah, we can represent the vector v as vx I cap plus vy j cap plus vy z cap, like this way. And if you want to add the vector v plus vector a, then we need to just add the components of this vector, like vx plus va. And in this case, we know that the vx and va are on opposite directions. So if we added this, then it should cancel out. Some portions will be left. So one of them will be always negative. So if we add vx plus ax I cap plus vy plus ay j cap, vz plus az k cap, this is the thing. This is why we are using these notations, and this notations is very useful for the vector addition.